Good day to you. This is ANAGALACTIC coming right back at you with the secrets of the universe. We are currently in a series of consolidation to get the rudiments of a new geometry. What is the sphere? The sphere is a peculiar object with respect to the line. I wish to dispel your fears. This is the most fun that a person can have. There's the point. This is what Euclid started with. There is the line. That is what the Greeks used and what you and I were taught in school. There's the circle, which is a planar object, meaning in our linear language it's 2D, but it's also a closed line. So there are those three objects. The point, which Euclid started with. The line, which is what he wanted to talk about, but we need to be sure of what Euclid did in the order in which he addressed these basic objects. There's the point, the line, which is open. A line is open compared with a circle, which is closed. Turns out that's extraordinarily profound, and that's how we're going to begin the Unimetrics series, but not at this moment. Later, we learned the circle. And much later, and not all of us, got to the sphere. It is possible to begin with the sphere the same way that Euclid began with the line. In this series, we're going to sum it all up from the bottom up. It cannot be said, because it can be proved otherwise, that Euclid knew about the number system associated with the straight line, the open line, as opposed to the closed line. I'm emphasizing that for a strong reason, which we're getting to in this presentation, which will be the only thing I want you to grasp in this one presentation, is the relationship that I'm going to explain carefully, including Euclid's approach. What is a point? What is a line? What is a circle? And what is a sphere? That's only 4 objects. I dare you to name another. If you're a mathematician or somewhat advanced into geometry, you might have a suggestion of something else. But if you say triangle, you're absolutely not following what's happening, because a triangle is made of lines. I'm just warning you so you'll be able to accept what I'm about to say, which is the relationship between these 4 objects is extremely important to understand. I give you the Vulcan sign of greeting, or whatever it is, peace. Just as with add and subtract and multiply and divide, when we look at the 4 basic objects, it's point and line and circle and sphere. Point and line go together. Euclid proved that. The circle and the sphere go together. That actually requires no proof, unless you want to get explicit and begin to use the relationship that you've discovered from this. This is the same break as in time-space, space-time, which is saying the same thing inversely. It's the same thing as light speed. It's basically the same thing as a lot of things that we take for granted. They're all in 2s. Add and subtract are in 2. Multiply and divide are in 2. I know I'm bringing in mathematics, but the reason for bringing in mathematics at this crucial moment of geometry, before I've said anything except what I've said thus far about the 4 basic objects, is that each one, this one, which has 2 things, and this one, which has 2 things, this is the circle and sphere, and the other 2, the line and the point, or the point and the line, if I'm going to put them in the same order, in their internal relation, the point to the line, the circle to the sphere. That's very simple, and the only objection which might arise, it would arise in my mind, is, so what? Here's so what. When you see that you have basically 2 basic objects now, because the point and the line are inseparable. It took about 2,000 years to discover that fact. So the point and the line are the same thing, numerically. That's quite profound, what I just said. That would require proof, because actually, that's not in our curriculum, that's not in our lexicon, that's not in our store of official knowledge. It's there. But knowledge is only useful insofar as you're able to use it, correct? That's obvious. So why don't we use the other of this? We've been using these two, the point and the line, in Euclid's order, point, line, but it's the line that we use. The point is carried along on the line. There's only one other object besides the line, and that is my hypothesis that I sought to prove in 2022 and did prove. That the line is a special object, extremely special object. That requires no emphasis because of technology, which comes exclusively from the straight line logic. Line broken into points. Those are called linear numbers. Now, the other object. What's the first object? Is it the point or the line? You could say both, or you could say line. That is the rudiment of superposition. Because when you're talking about the line, every time you talk about the line, you've defined the point according to the line. Because the line is nothing unless it's broken into points. Those are called numbers. And that's the correct definition of a linear number. So, what's the point? Still haven't gotten to the point. Don't forget, no one has ever seen this. No one has ever seen what I'm about to tell you. So it does require an extraordinarily rigorous form of proof, which I have done in 2 theorems, which are watertight and now have to be submitted to consensual science review in order to be sure that I'm not biased, missing something, or otherwise involved in a circular argument or just doing nothing of any importance because I made a mistake. That's the meaning of consensual science. But this is also part of science, although one has to feel a little bit alone at the time. So we have the line, which is made of points, is nothing unless it's made of points. And the purpose of this presentation is to make sure that you understand the 2 basic objects in the universe and the mathematics that we already know is associated with both of those objects. Now you know what Euclidean geometry is, no matter what anybody has said since. Euclidean geometry is this, and it is this alone, according to Euclid himself, and subject to morphological analysis, of which I am an accredited master, and this finalizes what Euclid actually said, because I can prove what he said. He began with a point, but he was trying to begin with a line, so he understood the underlying hierarchy between the 2 objects. He introduced the point first because he knew he had to. He had no interest in points. He had one interest, the line, the open line.
The open line. There are 3 versions of that line we were all taught in grade school. The line segment, that's closed. The ray, which is semi-open. And the straight line, which is doubly open on 2 infinities.
That is the full definition of the line. You're capable of doing this without knowing the diagrams to come, all of which you'll be able to download and study on your own from ANAGALACTIC.SPACE.
ANAGALACTIC.SPACE
will be in the description of every single one of my presentations from now on. That site will be a clearinghouse for your advancement. This is for you. All right. Thank you for tuning in. The second object is also dual, just as you noticed that the straight line is made of points. The first object, which Euclid discovered, which had to come first, we now turn our attention to the other object, which does not have points. We have 2 objects. We're now discussing the second one, the space of curvature. And if you want to say curved space, Einstein allows that. The sphere with its equator of rotation is a circle, with the circle embedded in spherical space. The line, which is open, not closed, not continuous like the sphere, not continuous like the equator of the sphere, which has energy on it, but the straight line is open to two polar infinities. That proves that linear space is embedded in spherical space. It can also be proved from that the universe is spherical in a geometric sense, which is something we need to step up to now, because we found out that everything in physics at both edges is spherical, not linear. And we've been measuring reality with linear numbers. And my discovery is you can now switch. The point is only on the line. The sphere has no points. They're proportional numbers, two fraction component numbers. Two componency numbers instead of one componency numbers. One componency numbers are points on the line. One component numbers are points on the line. Composed on this number, 1 over 1 times 1 over 1. That is light speed. How did Euclid begin with a point? Answer that now. You have 5 seconds. It was to quantize the line. Now, in spherical space, what do we need to do? We need to quantize the sphere. Max Planck did that for us. We'll be right back. Stay tuned. You won't want to miss any of the lectures to come. We'll be right back. Stay tuned and keep looking up, okay? All right.